functions and relation, definition, diagrams and inverse. The notation function A to B is used for a function. Okay, so it is called F with a set of inputs A. So the input A is the domain and the output B is called a codomain. The function F associates with each input in A, one and only one output in B. Some of the example, the application of function, you can read here. How to describe a function? First, give the function a name. You can denote it as F, G, or H. So these are the popular names for function. And then describe the domain, describe the codomain, and the last one, describe the rule. Example 1. Okay, give several alternative ways to describe the rule for the following function. Okay, let's say the name is F, and then the domain 1, 2, 3, 4, 5. And the codomain will be N. What is N? N is neutral number. And the rule, to each number in the domain, associate the square of the number. So when you write in the diagram form, this is your F, the function name, this is your domain here, and this is your codomain. And the rule that match domain to codomain is to each number in the domain associate the square of the number. So 1 square of 1 will be 1, square of 2 will be 4, square of 3 will be 9, and 4 and 5. Domain, codomain, number of function, and the rules. What is the difference between codomain and range? This is domain, and this is codomain. What is range? So let's say you have here A, B, C, and then it maps to 1, 2, 3, 4. Codomain is all the value in the output. Okay. And range is the value in the output that have the arrow from the domain. So this is your range 1 and 2. So I hope you understand what is codomain and what is range. You can see that range is a subset of codomain. Okay, function can be expressed in 4 ways. First, verbally, okay, by a sentence that states how the input is related to the output. And then algebraically by an equation in 2 variables, okay, fx equal to x squared. And also by graphically a set of point graph on the x, y coordinate plane. So this is graph for fx equal to x squared. Numerically, in the form of a table or a list of ordered pairs. Okay, this is in table form and this is in ordered pairs. This is your x and this is your fx. This is your x, this is your fx. Whenever a function is given by a formula in terms of a variable x, you assume, unless it is otherwise stated, that the domain of the function is a real number and the codomain also a real number, R. Okay, arrow diagram. This is your domain. This is your codomain. Example 2. Let f be the function of domain A, B, C and codomain 1, 2, 3. Defined by the ordered pairs A2, B3, C1. Okay. This is your arrow diagram and this is your ordered pairs. And another example, okay, S, A, B, C, and function N, S, 0, 1, 2, 3, where number of element is A. Okay, so 0. Okay, so this is your domain. This is your domain here. And this is your codomain. Domain 0, 0 element. So 0. 1 element. This one element, 1 element, 1 element. So it will goes to 1, 2 elements, 2 elements, 2 elements, goes to number 2. And ABC, 3 elements, will go to number 3. What makes a relation a function? So a function f from A to B is a binary relation with domain A and codomain B, with a property that for every x is the element of A, there is exactly one element y, element of B, for which xy is the element of f. We see that in practice, to be a function, a relation must satisfy two conditions. Number one, every element of the domain must have something associated to it. And number two, no element in the domain can have two things associated to it. Domain only can have one arrow. The relation of function, okay, this is function and this is not a function. Okay, a function must one to one or many to one. So this is one to one, okay. One in one domain to one value in codomain. Okay, that is one to one, and one to one. Another function is many to one. Many to one, 1 to D, 2 to C, also 3 to C. Function can be one to one and many to one. So one to many and many to many, this is not a function. Okay, for example, this one x. Okay, the output will be D. 1, the output will be D. And 2, the output B and C. So this is not a function. Okay, similar to this arrow diagram. Example 3. Determine if each of the following relations are function. Fx equal to x plus 2. Okay, for each value of x, element of R, the value of fx, x plus 2 is unique. So the relation is 1 to 1. So this f is a function. Okay, similarly, x squared plus 3x plus 2. So when x equal to 0, g0 will be 2. When x equal to negative 3, g negative 3 will be 2. Okay, there exist two values of x with the same image. Okay, so the relation is many to 1. So this g is a function. Okay, number 3, function h plus minus square root x minus 2. Okay, for each value of x, with x is greater or equal to 2, there exist two possible values of hx. Okay. For example, when x is equal to 6, so h6 is equal to plus minus 2. So the relation is 1 to many. So this h is not a function, because with one value or input, it will give you two output. So this is not a function. Now let's look at the special types of function. There are three special types of function. The first one is one-to-one or injective. In one-to-one, each element in the codomain is mapped to by at most one element of the domain. You can see here, no two arrows end at the same element of the range. One domain to one codomain. And onto function, each element of codomain, this is codomain, each element of codomain is mapped to by at least one element of the domain. So each of these being mapped from domain at least one time. So you can see that every element of the range is the endpoint of some arrows. The last one, bijection. Okay, bijection have both one-to-one and onto. Every element of the range is the endpoint of exactly one arrow. Number of domain is equal to number of range. This is one-to-one. This is onto. This is bijective. So what is the difference between one-to-one and bijection? You can see here, in one-to-one, there are one element in your codomain that not being mapped. There are one element here that not being mapped from the domain. And onto, everything here is the endpoint of some arrows. So here, everything here is the endpoint of some arrows. Okay, that's all for today. Thank you.